We're continuing to look at vertex form. As a reminder, the equation for vertex form gives us that vertex or turning point right in the equation. The opposite of h is the x-coordinate of the vertex, and k is the y-coordinate of the vertex. We're also going to learn about something called the axis of symmetry, which is an imaginary line that the parabola can get flipped across. The equation, because it's a vertical line, is an x equals equation, and it equals the x-coordinate of the vertex, or h from the equation. Our essential question today is, how do we interpret the equation of a quadratic function? For each of the equations in vertex form, we're going to find a lot of different information about it, all just from the equation, none of it by looking at the graph. So our first question is, does the graph open up or down? The way that we determine that is by looking at the a value of the equation. That's what's being multiplied out front before the parentheses. If that a value is positive, our parabola opens up, and if it's negative, like ours is, our parabola will open down. The vertex, remember the asylum, so we get the x-coordinate of the vertex from inside the parentheses grouped with the x, and we make it opposite, and then we get the y-coordinate of the vertex from the number outside the equation, and it stays normal. Axis of symmetry. This is the vertical line that the parabola gets flipped across, and it's x equals the x-coordinate of the vertex. So that you have a little idea of what that axis of symmetry is, if we sketch our coordinate plane, the vertex of our parabola is at 1, 4, and our parabola opens down. That's all we really need to worry about for this sketch. The axis of symmetry goes right through the vertex, right through that turning point. And you can see if you flip that parabola across that imaginary line, it will land on top of itself. So the equation for that vertical line is x equals 1 in this case. It will always be x equals the x-coordinate of the vertex. To find the y-intercept for any function, we substitute 0 for x and solve for y. Order of operations will work inside those grouping symbols first, 0 minus 1. Second step in order of operations, we will square that negative 1. Remember, when you multiply something by itself, it becomes positive. Negative 3 times 1 is negative 3, plus 4 is 1. So the y-intercept, we started by substituting 0 for x, and we solved to get 1 for y. Domain and range. Domain for all quadratic functions always is all real numbers. We can square anything. And the range depends on the y-coordinate of the vertex and whether or not our graph opens up or down. Our graph opens down, so y is less than or equal to the y-coordinate of the vertex. We'll take a look at one more in this video, and that'll leave the last example. We'll take a look at that together in class. Does our graph open up or down? That comes from the a value, what's being multiplied in front of the parentheses. If it's positive like ours is, it opens up, and when it's negative, it opens down. The vertex comes from inside the parentheses grouped with the x and its opposite, and then the number that's on the outside being added or subtracted, and that is normal. It's negative 9, so negative 9 is the y-coordinate of our vertex. The axis of symmetry is an x equals equation. X equals the x-coordinate of the vertex. That's that vertical line that the parabola could get flipped across. Y-intercept, we replace x with 0 and solve for y. Again, following order of operations, inside the grouping symbols first. Then we will do our exponent. 5 squared gives us 25. Multiplication, 2 times 25 is 50, and 50 minus 9 is 41. So the y-intercept is 0. We started by substituting 0 for x, and we solved and got 41 for y. Domain and range. Domain for all quadratic functions always is all real numbers. and the range y. This time our graph opens up, so it's greater than or equal to the y coordinate of our vertex. If you feel like you understood the information in this video and you would like to try the U-Try question, here it is.